Greetings and welcome to Ice Age Floodscapes, an online YouTube channel devoted to the science behind giant megafloods of the Pacific Northwest. This video focuses on Montana's Eddy Narrows. Oofda. Eddy Narrows played a significant role in the draining and flow of many dozens of Ice Age megafloods from Glacial Lake Missoula that occurred as recently as 15,000 years ago. Eddy Narrows lies along a constructed portion of the northwest flowing Clark Fork River Valley. It is less than a mile wide and 8 miles long. The ice dam for Glacial Lake Missoula once lay 50 miles down valley of Eddy Narrows near the Idaho-Montana border. After each breakup of the ice dam on the Idaho Panhandle, the contents of Lake Missoula would catastrophically drain down the Clark Fork River Valley, all in a matter of a few days or less. The beautifully preserved rocks along the near vertical walls of Eddy Narrows belong to the Belt supergroup. These are mostly ancient river and lake deposits laid down along the western margin of the Columbia-Nuna supercontinent about 1.5 billion years ago. That's billion with a B. These extremely old rocks, composed of mostly metasedimentary argillite and quartzite, are especially hard and durable and resistant to weathering. Fossils are generally lacking in these rocks, since they were deposited before the evolution of any plants and animals, with the exception of an occasional primitive algal mat layer. The complete absence of any burrowing plants or animals accounts for the wonderful preservation of the sedimentary features we see in these rocks today. As belt rocks weather, they separate along ancient bedding planes, creating tabular rectangular blocks of mostly argillite and quartzite. Their distinctive shape makes them well suited for the use in man-made rock walls, like the one shown here. Belt rocks also weather into a wide range of colors, from black and gray to various shades of blue, green, tan, and maroon. Belt rocks make up about 10 to 20% of all ice-rafted erratics transported downstream into Washington and Oregon by the Missoula floods. Here are some examples of ice-rafted boulders from the Belt supergroup, transported in floating icebergs far downstream from their place of origin during outburst megafloods. Erosion along Eddy Narrows was locally more intense compared to other areas within Lake Missoula because of the Venturi effect, which caused floodwater to flow faster through this narrow constriction. The temporary increase in velocity of the floodwaters in the narrows swept away most loose debris off the canyon walls, beautifully exposing the belt strata underneath. The highest elevation for Lake Missoula was 4,200 feet, based on the maximum height of ancient bathtub ring-like shorelines, also called strand lines, still visible today around the perimeter of former Lake Missoula. When Lake Missoula was at its maximum level in Eddy Narrows, it rose 1,800 feet deep above the present valley floor. Knowing the flood depth in an average cross-sectional area of 5.9 million square feet, geologist Joseph T. Barty in 1942 estimated a maximum flow rate for the floodwaters through this constriction at 385 million cubic feet per second. More recently, USGS geologist Jim O'Connor in 2020 revised the estimate threefold to about 1 billion cubic feet per second, based on some more recent data. To repeat, during its maximum depth and volume, Lake Missoula would have taken only a few days to drain after failure of the ice dam. The evidence for the sudden and catastrophic draining of Lake Missoula is indisputable. Besides the reaming out of Eddy Narrows, other strong, convincing evidence for megafloods coming from Montana are giant current ripples along the floor of the valley of Camas Prairie, upstream of the Narrows. Additional evidence includes visible flood eddy bars, or gulch fills within the tributary valleys of Glacial Lake Missoula, perched high above the valley floor, deposited by the escaping floodwaters. Equally convincing evidence for outburst floods comes from the ravaged areas downstream of Lake Missoula, including the Channel Scabland and the Columbia River Gorge. Thanks for watching. Rock on.